So this example here, when we try to apply the parts to this, okay, so we're going to let the u part equal x to the power 4, and the dv part is going to be my e to the power x. Okay, so I get du is equal to 4x cubed dx, and my v part becomes e to the x. Okay, so this is dx here. Okay, so there are my parts. And when I try to apply this integral, I'm just going to do it down here. I end up with u times v, so x4 e to the x plus, minus the integral of v du. So it's going to be 4x cubed e to the x dx. Okay, so now it's important to take a look at this, and we can't really integrate this, and that's a big problem. So we haven't really gotten very far, but we have made some progress, and these types of things do happen. So here I've integrated this, I've rearranged this basically, and I have an integral that I can't integrate yet. Notice that the power has been reduced by 1. And so as I apply, if I'm going to apply this again, you'll see that this power, every time I choose a u, the du becomes 1 power less. And if I reapply this onto this integral here, okay, if I apply parts onto that, reapply parts onto that, I will be able to reduce this down into a power of 0 basically, and allow will eventually generate an integral that I can do. So I'll show you how this works. So I'm going to reapply this again. So u this time is going to be x cubed. My du is going to be 3x squared dx. My dv is going to be e to the x, and so we're just going to have my v equaling e to the x again. Okay, so the e part is kind of nice because it just works out nicely every time, and this is my new integral. So this part has been worked on already, so we're just going to leave it, minus 4, and then this rest of this will be my new integral. Okay, so I'm going to have uv, so it's going to be x cubed e to the x minus, so that's a minus minus, so we have to watch our signs now, the integral of 3x squared e to the x dx. Okay, and then again I have this integral here, which it's a little bit easier to work on, so then I'm going to reapply this again. So I'm going to need a little bit of room here, so u is going to be equal to, in this case, x squared. My dv will be equal to e to the x again. Du is equal to 2x dx. V is equal to e to the x. And I'm going to reapply this formula. So the parts that have already been resolved here are x4 e to the x. And you notice there's actually a pattern that's going to form as well. Okay, we're not going to really so much get into the pattern, but there is something called integration, tabular integration by parts that takes advantage of this pattern. Okay, so this is going to be x cubed e to the x. I'm going to write this as plus 3, and then this part here now is going to look like this. So this is going to be, I'm going to apply the parts to this part. So here is going to be x squared e to the x. Okay, I made a mistake here because this negative 4 has to apply onto there, so it becomes positive 12. Okay, so that coefficient, I have to make sure that I apply that coefficient across. Okay, so that's moving on with that, the rest of the green part there. So I've applied the first part of that. minus the new integral is going to be 2x e to the x dx. And although I cannot solve for this yet, I can see that if I reapply this again, I'm going to be in a situation where I can finish off this integral. So I'm going to do this last part in blue. Okay, so I'm going to let my u again. U is equal to, in this case, x. Du equals dx. dv is going to be my e to the x. My v times dx. My v is going to be e to the x. Okay, and then I can apply this again. So I just have to make sure I'm keeping track of all the other parts here. So this is going to be equal to x to the power 4 e to the x minus 4. I'm just going to keep it in, actually I'm just going to do that in black. X cubed e to the x plus, okay, so I'm going to multiply that 12 in, so I end up with, so I'm going to do this in green. I end up with 12x squared e to the x minus, so that plus 12 multiplies onto the 2, so I get 24, and this integral now becomes, okay, so this integral here is going to be done in blue. That integral now becomes the uv, so x e to the x minus the integral of e to the x dx. And again, now that can be easily resolved. So as I work out the rest of this, okay, x4 e to the x. So it does involve quite a bit of keeping track of in terms of your accounting skills. Okay, so I've done this in colors to kind of help. If there are multiple steps, we probably want to learn a technique called tabular integration, which takes advantage of the patterning that's evolving here. So plus 12x squared e to the x minus, and this becomes 24x e to the x plus 24, and then the integral of e to the x is going to be e to the x. Make sure we put a plus c in there, and there it is. We've got the integral, although it took a number of steps. We applied integration by parts once here, twice, 3 times, 4 times to be able to get rid of that power 4. Okay, but eventually we ended up with an integral that we can integrate. Okay, so this is repeated integration by parts. This next one is fairly similar. There's some similarities to this, in that when we do this, we're going to find that, let's do it and see what happens. Okay, so I'm going to choose sine x or e to the x as my dv. Now, in this case here, it's hard to decide which is the harder one, so you can just take a guess and see if it works. In the end, for a problem like this one actually doesn't matter which one we choose as our dv function. Okay, so I'm going to let u equal sine x, and then my dv equals e to the x dx. Okay, so I end up with v is equal to e to the x, and du is going to be equal to cosine x. Okay, so setting up my new integral, so this is going to be equal to, I'm going to write it like this, equal to uv, so e to the x sine x, okay, plus, minus v du, so minus e to the x cosine x, we've got dx here, times dx. Okay, so there's our new integral. This is a bit of a problem here because really I haven't gotten anywhere. Right? I start with sine e to the x, and I end up with cosine e to the x. Well, that's not particularly useful. Well, let's try it again. So we're going to try it one more time. So we're going to do, and again, since I'm doing it repeatedly, I just have to make sure I keep track of all my stuff. Minus, and I'm going to apply my in here, so I'm going to apply it to that. And so this is going to be, I'm going to let u equal to cos x this time, and then my dv is going to be the same, e to the x dx. My du is equal to negative sine x dx. Okay, and my v is going to be e to the x. And so when I apply my integral here, my integration by parts formula here, I'm going to end up with e to the x cos x. Okay, well that's fine. So it's going to be minus, it's going to be du is negative, so it's going to be plus. Okay, so I'm going to end up with the integral of e to the x. V du is going to be sine x dx. Okay, so there it is. I'm just going to move this over a little bit so I can have a little bit more room to work. Okay, so there it is. There's my sine x. This is my new integral. Again, I haven't gotten anywhere. This is exactly the same as what I started with. So I've just gone in one big circle. This seems like a complete waste of time. However, this is actually ideal, because if we can generate the exact same expression here and here, we can now do some algebra to this. Because if I write this in, so I'm just going to write this in on this side of this. Remember, this is an equation. This is just an equality. Okay, so I get e to the x sine x dx is equal to that. Okay, well, I have this expression the same here and here. In fact, this is a negative one, so I can actually group these together and just say that I have two of those expressions. I can just treat this as like a, for example. This is a, negative a, so I actually have two a's on the left-hand side of the equation. So that's what I'm going to do. I'm going to rearrange this so that I have 2 e to the x sine x dx is on this side, and on this side I'm going to be left with e to the x sine x minus e to the x cos x. And if this is really true, then I've pretty much solved for my original integral. I want to know what that is. Well, I can say that this original integral is equal to this divided by 2. So this is my solution. And this is going to be equal to e to the x sine x minus e to the x cos x all over 2, and don't forget the plus c because we've found an indefinite integral. So there it is. So this is one where if we end up back where we started, that's not necessarily a bad thing, because we can actually algebraically treat that as an algebraic piece. And again, here I treated that as an a, and here I treated that as a negative a, and was able to group them together to make a 2a on this side. Okay, and that allows me to then solve for that a value, which is the original integral which I wanted to solve for in the first place.